So in the last video, we found the revenue function corresponding to a certain demand function. And the R versus P function is clearly quadratic. You got a P squared, you got a P. You don't have an independent constant over here, so your constant is 0, but this is certainly a good quadratic function. We want to find the zeros, intercepts, axis of symmetry, vertex. Of course, the zeros do give you intercepts. Those are the x-intercepts. We want to find the y-intercept and so forth, or the r-intercept. So, to find the zeros, we set -5p squared plus 200p equal to 0. And this is actually very easy to solve by factoring. It's the easiest type of factoring. We can factor out p. We get p times -5p plus 200 equals 0. And the zeros are when one factor or another. This has two factors, factor here, a factor here. One factor or another is 0. So p equals 0, right there's one of them, or -5p plus 200 equals 0. So that we have p equals 0, or solution to this equation. I'll solve this equation before I do. Pause, take whatever time it takes, and quickly solve that, or slowly, I don't care. Solve that equation. Actually, I do care. I hope you can do it quickly. But if it takes you a little longer, well, you need to practice then. Okay, well, to solve this, we're going to subtract 200 from both sides, divide both sides by -5, and we're going to get p equals 40. Those will be the zeros. If you remember, and hopefully you made notes and a picture of the pretty parabola I drew on the last problem, or the last video, you see that this agrees perfectly with the intercepts of the parabola that I drew. The intercepts, y-intercept, or the r-intercept, and remember we've got a graph of r versus p. The r-intercept is when p equals 0, giving us what? If p equals 0, what is r? Pause, do that before I point it out. Okay, put in 0 for p, you're going to get 0 for both of these terms. You're going to get r equals 0. So, and of course that's kind of obvious. If we graph the zeros, p equals 0 gives us 0, and p equals 40 gives us 0. That's also an r-intercept. Okay, so the r-intercept is the same as the p-intercept at 0. Okay, what else? Well, now if you didn't already know, how would you find the vertex of this parabola? Okay, you should pause and do that. To find the vertex of this parabola, let's say the axis of symmetry. Okay, now we'll find the axis of symmetry and use that to find the vertex. Okay, what's the axis of symmetry? Well, the axis of symmetry is the point about, or the axis about which the parabola is symmetric. And that axis of symmetry, if the parabola is going to be symmetric, then the 40 and the 0 here have to be at equal distances on opposite sides of the vertex, so or opposite sides of the axis of symmetry. So here's your axis of symmetry. I can't write it down, but that's halfway between your zeros, and that's going to be at started to write x. It's at p equals 20. So here's your axis of symmetry. Now there's another way you could have found the vertex and the axis of symmetry using the quadratic formula. Okay? Alternative. What does the quadratic formula tell us? Okay? Why don't you see if you can do that? Pause and see. Okay? Hopefully you paused and you've thought through what the quadratic formula tells us about this. Okay, well, negative 5p squared plus 200p is of the form, it's not ax squared plus bx plus c, not at squared plus bt plus c, but ap squared plus bp plus c. Okay, it doesn't matter if this variable is x, t, q, p, or aardvark. It makes no difference what we use for the variable. The formula tells us what it tells us. So that, and this is with a equal negative 5, b equals 200, and c equals 0. So the zeros are at negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And when we plug that in, we're going to have negative 200 plus or minus the square root of b squared, that's 200 squared, minus 4ac, c is 0, so 4ac is 0. So that's just 200 squared minus 0, all divided by 2a, and a is negative 5, so that's 2 times negative 5. And what do we get? We get negative 200 plus or minus the square root of 200 squared. Now we could multiply that out, it's 40,000. We could then use a calculator to find the square root of 40,000, or if we got good number skills, we could figure that out without a calculator. But the square root of 200 squared is 200, so we don't really need to do too much more with that. And this is over negative 10. And you should pause for a second, see what you get from these numbers. But we're going to get p equals 40 or p equals 0. Negative 200 plus 200 is 0, divided by minus 10 gives us 0. Negative 200 minus 200 is negative 40. Negative 400, negative 400 divided by negative 10 is 40. Yeah, we got that. Okay? And the axis of symmetry is what? Well, how do you get the axis of symmetry from the quadratic formula? It's the negative b over 2a, which is halfway between negative b plus this and negative b minus this over 2a. Okay, axis of symmetry, p is negative b over 2a, which is the negative of 200 over 2 times negative 5, which is 20. P equals 20. So this confirms everything that we've conjectured to this point, confirms the axis of symmetry that we conjectured here and in the preceding clip, and it validates our zeros. The last thing we want to do is find the value. Okay, find the vertex. So where's the vertex? I'm going to do that up in the corner here. It won't take much room. Vertex equals what? You should pause and do that. Now I'm going to go ahead and do it. The vertex is on axis of symmetry. Which is P equals 20. So R of the vertex equals negative 5p squared plus 200p, whatever p happens to be. Well, p happens to be 20, so that's negative 5 times 20 squared plus 200 times 20. And if you figure that out, you ought to be able to do that in your head. 20 squared is 400. 5 times 400 is 2,000. And I'm getting a strange result here. I'm getting 4,000, which makes me wonder. Oh, sorry. Okay. Yeah. Talk about numbers since I didn't have any up there for a minute. 200 times 20 is 4,000. 5 times 20 squared is 2,000. That's negative. 4,000 minus 2,000 is 2,000. Hopefully you saw that before I did. So now our vertex is at 22,000. And that also agrees with everything that we've conjectured up to this point.